ready for commissioning, so we need to introduce a fluid into the system. We don't want to put plain water in there, do we, really? What we need is something like our FRNOX Solar S1. And what that does is that's a fluid that will withstand extremes of temperature. So in the winter, we'll have frost protection down to about -28, and in the summer, during peak periods, the fluid will be okay at temperatures above 200 degrees C. So what we don't want is that fluid decomposing or any contamination in there. And the Solar S1 also contains what's called an inhibitor to stop any corrosion, because we've got mixed metals in our system. So what we need to do is somehow get that chemical from that drum into our system. So we've got this fantastic simulation here. So this is our solar panel on the roof, and this is our dosing mechanism that we're going to use to get our Solar S1 into the system. And essentially, it's a pump and a tank. Now we've got a couple of options here. What we're going to do for today's demonstration is we're going to pump from the tank on the pump straight into the system. There is facility on our solar flow pump to actually siphon straight out of the drum into the pump and then into the system. So the choice is yours, but for the purposes of today's demonstration, we'll do it this way. So we've got an inlet and an outlet. We're going to take the outlet hose from our pump into the inlet of the system. This kind of makes sense. So that will then dose up into the panel, and then we've obviously got to have a return because we want a closed circulation loop. So we'll take the return, the outlet, back into the top of the tank. Now it doesn't just drop into there, it drops into what's called a dip pipe. So the pipe then enters into the tank and finishes up below the level of the fluid. And the idea of that is to remove any air bubbles from the system.
And that's critical, isn't it? Removing the air.
Absolutely, absolutely critical, because we only want fluid circulating in our panels. Because if we have air, once it gains temperature and gets hotter and hotter, the air expands and becomes a bigger problem. So we absolutely don't want that. So we've done the connections already. So essentially, we've put the fluid in there. So all we're going to do is turn the pump on and then dose our system.
And Rich, how often should you do the maintenance of it? You know, how regularly?
I would say that typically you want to check the level of the fluid, the Solar S1, about annually. And the reason for doing that is because one of the biggest problems with these systems is something called stagnation.
Yeah.
We're dosed and ready, commissioned already, all the air's out of it. Stagnation is when your tank of hot water, which is heated by your solar panels, is satisfied, so you've got no more demand for heat. And what happens then is the fluid just sits in the panel and will heat up and heat up. And that's very bad for solar fluids. Ours is obviously buffered to take care of that, but the longer it's exposed to periods of extreme temperature with no flow, the higher the stagnation period, which causes degradation. So it's a long way of saying that basically check it once a year. It's an easily done test using a refractometer. Take a small sample, look at it, check the concentration. If it's okay, fine, we're all good to go. If it's not, then you'll probably need to add some more using the solar pump and do it exactly as Mo here has dosed it in. Very simple to do.
And get the equipment from Plum Centre?
Yeah, Plum Centre keep these in stock. Fantastic price. Why go anywhere else?